Welcome back, everyone. This is the last session of the day. It will be our least formal, and we've been blessed with Matt Ahrens and George Wilson, among other people trickling in. I hope your flights weren't delayed or anything. Cool. So I was calling this I Learned, Show and Tell, and War Stories. And it's pretty fair game. I have a very quick This I Learned to kick it off with, and I've got a war story that we can save if we're needing to fill some time. So this I learned. You can do things like ZFS list-t snap for snapshots, which is awesome. There's a shorthand. And then I thought I'd do ZFS allow Dexter snap to allow snapshotting. And it's like, you're crazy. I'm like, let me try it again. And you do need to spell out snapshot when allowing. And it hadn't occurred to me, just as a user, that the shorthand might not apply everywhere. And I believe based on a conversation online or on a Taipei train platform, Rob Norris kindly allowed for ZFS list-t FS, short for file system, because typing all those characters for file system was a bit over the top, although there is snap for snapshot, etc. So the thing I learned is just to be verbose on all but listing when using shorthand, and hopefully that shorthand will trickle into all possible operations naming such things. There we go. Other stories, and this I learned. Yes, sir. Gary.
Oh, okay, this is just very short, but in sort of the same mode, I always get used snap and snap used backwards or reversed. I hope someone is going to fix that someday, or at least make them be aliases, because also, like, you have to type it one way and ZFS list displays it the other way.
I learned something today, actually, because it's something I was just only trying to do it on my laptop, which is why this manifested, because obviously it's smaller than most production systems. So I'm like, okay, let me just make, 10 disks, small size, and just kind of set up a mirror pool and, play around with it. Well, I did that, and I tried to create the pool, and then I started getting this cannot label area, I could show you the error. And I'm like, that doesn't make any sense. And so I didn't label the disks. I ran ls block that there was no partition. I just added the disk. It was fine. And so I couldn't find anything on the internet about the specific error. And then I talked to Alan, and he was like, well, how big are the disks? I'm like, I just made them like 50 meg, and he's like, well, the minimum disk size is 100. So
64.
so that's why I got that very nondescript error that I was stuck on for about 20 minutes. So
Understood.
I'll throw it up on the internet somewhere, so next time somebody else comes across it.
General piece is problem. Just a reminder, 64 megs, but our team, we were investigating an issue with ZFS where at some point pools were not imported. In some cases, appeared that if you hit before ZFS on a file system, on a partition you had some other file system, ZFS on Linux in block ID appears after other file systems. So block ID first sees labels of ext4 VMFS, who knows what, and after that the pool import doesn't see anything. So and while investigating, that's one issue, and obviously that's probably gonna stay, but at least we found that implementation of block ID, of probing of ZFS labels is not the same as one used by ZFS native. So Amir Hamza from my team is right now rewriting that part to hopefully make it work slightly better. It is consistent with kernel.
Rod had asked if anybody knows the history of why 64 megabytes is the minimum disk size.
Initially, like when we did Z-test and some of the testing utilities, like you needed so much to run the tests, or they would fail. And so, and I think it grew over time because I think 64 meg was kind of what we found was, sorry, so it actually kind of stemmed from some testing that that was actually implemented for ZFS, and to get the test to actually run, because when you create the pool, you have like so much kind of slop space that we keep around, and so we needed disks that were big enough to allow you to be able to like run tests and still have enough space for like all the metadata that we maintained.
And to copy and write all that metadata.
Yeah. So we kind of landed on 64 meg, but I seem to recall that at some point in time we had to increase it because there were other tests that started failing, and we ended up going with a larger size. But
I think it's the same problem.
yeah, it was the same problem. It was like as tests kind of grew and different functionality came in, we just needed more and larger kind of small disks, and that's why. Although I swear at one point in time it did tell you the minimum size, like it wouldn't give you a cryptic
I think
error.
in this case they were 8 megabytes, and by default ZFS on Linux tries to create a small reserved partition and then the ZFS, and that one needs to be, I think, is 8 megabytes, and so it couldn't actually create the partition it was trying to create because it was bigger than the whole disk.
Didn't get that far, yeah.
But yeah, there are quite a few times where the error message, you know, because error nodes generally have one text description, it often isn't actually telling you what the problem is.
I was going to say it would be good if there were some more uprintfs in the code that basically let you know when you were trying to do something stupid that ends up, you know, when it comes out of the kernel just as, you know, enval or whatever, because there's a lot of different things that all map to the same erno, and if you don't know which thing you're doing, I mean, it's, you know, it's like Ken Thompson's editor. It's, you know, you do something wrong and it just displays, huh? And it, you know, there is information in there that would tell you what you did wrong, but there's just no way to pass it back across the regular, you know, syscall API. So,
Well, I think my favorite example of that one is generally the way the error is formatted. It has like the command that gave the error and then thing. And so if you have a shell script with an invalid shebang line, it says binsh file not found. It's like, but binsh is right there. What do you mean binsh is file not found?
I have a support horror story. Oh, Halloween's coming up, so we've got some candy back there. But yeah, yes, my phone will do that. So there was a user with an early Proxmox system, and on ZFS naturally, and they did everything right. They had a nice snapshot policy, and they retained snapshots for 6 months, diligently. But there was, hopefully it's gone, a bug in Proxmox that allows you to delete a VM. And they deleted an active VM that happened to be their mail server. But the OS held on to all of the resources for 9 months. And they finally found a service window. So after 9 months with a 6-month retention on snapshots on a VM that's diligently snapshotted for 6 out of 9 months, they finally did their updates, rebooted the host, and asked each other, where did the mail server go? It's just gone, because finally the OS released all those resources, and had they kept it booted and known, apparently through the virtual file systems, they could have probably reconstructed through all the stuff in Linux with virtual file systems and said, this is my backing storage, let's make a copy to somewhere. But no, it diligently cleaned up, and they scratched their heads with all this free space. Ooh. Other stories, questions, ideas, t-shirt slogans?
Oh, I had an idea for a meme just now. That's what I was talking
Oh, please.
about.
Do you need a mic?
Mr. Incredible one, I could probably yell.
Right.
But I mean, it's not that.
You can't yell to the internet.
You can't yell the internet.
You can yell on the internet to the internet.
That's a long one. Yeah.
Has everybody seen the like the Mr. Incredible memes where it's like Mr. Incredible's face normal and then like black and white and like saturated? Yeah. Or it's just like, oh, we freed up a bunch of space. Oh, we freed up a bunch of space.
Yeah. Boom.
That was
The
not,
good news is.
Thank you for the effort.
But, my other meme that's similar to that, I mean, it would be something along the lines of, it's one of my favorite quotes for anybody, like, we're all about the same age. I would like to get that meme of like in Top Gun when he said, where'd Hollywood go? Like, where'd your data go? Where'd what go? I think that would be a really good one.
So I actually wonder if anyone has had to deal with discovery and finding out that they had snapshots that they weren't intending to keep, that now they have to give to somebody's lawyers to sift through. Because occasionally, like, our snapshot policy fails to delete things that it's supposed to delete.
My primary snapshotting technique is kind of stupid and does run into that problem, but I haven't actually met with lawyers on it. So, and the only time that I've had to dealt with it broke in my favor because similar situation where somebody deleted something and needed it back further than what our official window was.
I hadn't encountered that, but I had encountered once the opposite, when at the end of the case, the lawyer needed to destroy all of the data and not have it anymore, but didn't want to lose everything else that was in the snapshot. And it's like, that's why you need separate data sets.
I do have a customer that does regularly have notification for lawyers type of stuff, and they ask for the opposite, and they say, do not delete this snapshot because we will have lawyers coming and looking at this. So
So do you
holds
use
work
holds?
great.
Yes.
And export and clone. This is the potential for legal. It goes into a different thing and it's only managed by 2 people. That's how we manage that cost.
Are there any lawyers in the house?
Who would admit to being lawyers?
Any success stories where, for the win? I'm sure some of you have countless ones, but
I'm afraid I've already given away almost all of my war stories earlier today. So
it's okay. You've got some new audience members. But.
So, and the big success story, which has also been kind of a pain for the last, 14 years now, was, our old NAS equipment, which was Blue Arc, and I think some people still were trying to keep some NetApps going, was end of life. And, my group was asked, how can we not have to pay $500,000 to replace all the storage that we have? They had been, there was a history of some really random Linux servers, and before that, Sun servers, which tells you how long this history goes back, that people were unhappy with the performance of, which caused them to buy the specialized hardware in the first place. But nobody could really tell me what were these workloads. But since one of our industrial sponsors, a company you may or may not have heard of called Quanta Computer, they make half of the hardware that you use in China. They gave us a bunch of hardware, including a platform that they had originally developed for Korea Telecom, which was half a rack that was a 2U server, and then 4 24-bay JBODs with a SAS, SAS interconnect. Thankfully, I didn't have to deal with like any RAID cards or garbage like that. So I said, hey, we have FreeBSD expertise. All my FreeBSD systems run ZFS. This seems like it would be an ideal platform to run ZFS on, particularly once I put some SSDs into this storage array. And we did that. And then I became the storage guy, which was not really my intent because I'm the network guy. I already do 3 jobs. I didn't need a 4th job, but that's how things work out when you're small and nobody wants to spend money on infrastructure. So even when in the future we had to actually buy hardware instead of getting it for free, it's still like a order of magnitude difference in cost between what we can buy or what we can tell our researchers to buy is closer to the truth. And even compared to some of the more economical platforms like the TrueNAS platform on the hardware that IX Systems sells, we're still like half of the cost of that. And most people are happy. The people who are unhappy are people who are not really using the file system very effectively, or at least they're not using NFS very effectively. And they're unhappy about performance, even though even on our oldest servers, they're really not getting anywhere close to exercising the full performance of the server, just because like their Python scripts are shit, excuse me. And that has worked out pretty well. We're now on our 6th or 7th generation of hardware, because we've expanded from 1 server to 4 servers, and then now we have about 20 plus or minus. There's some that should be going away, and we mostly get them from white box vendors that we like. IX Systems has generally been pretty competitive for those, but we have another vendor that we also like to give some business to because we want to maintain that relationship. And if there's no difference in price, it's like at some point we have to give them some of the goodies too.
Spinning disk or flash?
Sorry?
Spinning disk or flash? Or both?
Almost all of our stuff is big spinning disk. Our most recent build was 60 22T drives, because that is kind of where the market is right now. We don't want it to be any bigger in capacity because our users can't really fill it. And particularly if it's going to go to a single user, which is how most of these things get built, they really, it's 560 terabytes. I should mention we basically stopped using, we were using RAID Z2 in our initial build, and we've gone to 100% mirrors.
Really?
Because, I don't ever want the user to come to me complaining about performance and have it turn out to be, 3 years ago you didn't build this pool with enough VDEVs. And okay, well, I can just give, what is that? That's 28 VDEVs of 22T drives gives you 560 TB, to use the IEC terminology. And mostly we're pretty happy with that, except for how it interacts with our old backup system, which we've basically, a lot of the users have said, well, you know, if it's going to interact that badly, then we're just not going to back up our stuff. That's like, well, okay, so long as I have that in writing, then that's what we'll do. We obviously can't do that for everything. Some stuff actually has to get backed up. But, you know, it's really worked out pretty well, and it's saved people probably on the order of $2 or $3 million. Although, okay, so one thing I did learn recently that I just remembered. ZFS list. Is it ZFS list? No, it's ZFS user space uses the incorrect prefixes for user object used. It uses the binary prefixes. And objects are not inherently power of 2.
Yep.
I noticed this because df-I disagreed with what ZFS user space was telling me.
That sounds like a good hackathon project to fix.
Yeah. That's it for me.
Yeah, I don't know if it's really a war story, but I think that the craziest thing I ever did was ZFS. Had a customer. It was a university that had a distributed file system built on top of ZFS. And so they had 24 different pools across different machines and a complicated HA system to fail them over. But the one thing they had never considered might fail as part of their HA system was the switch, the network switch. And so when the network went down, their HA system decided that the other node was down and that I should import the pool on this node. But every single node decided that it should be the one to import. So all 24 pools were dual imported on the A and B head for at least 45 minutes, taking turns overwriting each other's Uber blocks.
That's LOTF failover.
Yeah.
Lord of the Flies failover.
Yeah, very much lacking a shoot the other node in the head mechanism. But we managed to get most of the data back by rewinding the pool to different levels of different transaction groups and getting back different data sets and a week of craziness. But there was one data set where all the data was fine, but not the root directory, but one of the subdirectories under the root was corrupted. And that one, all it contained was the one directory that then contains all the files. And it was gone. There was no way to get it back. And so I wrote the Linux equivalent of what a sysctl would be, where a tunable that when you write to it, it runs a function. And so you echo an inode number into this tunable, and there's one tunable that you set a data set, and the second one you write an inode number into it, and it reconnects a file with that name and that inode number into the root directory. And then suddenly the files are accessible again.
Lost and found.
Yeah, basically a manual lost and found mechanism for directory entries. And that is the dirtiest thing I've ever done in ZFS.